in full screen. Does anyone need help with that? Anyone? Are you okay? Everyone okay?
Yes, we're good. Yes.
Okay. I had prepared a discussion for tonight, but I'm going to move it to the 31st. So that's what I'm doing right this moment, so you don't have to worry about that right now, because I talk too much. Sorry about that. Okay, so first of all, I would like to start with something very simple, which is graphing the line. And also a quadratic function. So a line is something like f of x equals 3x minus 6. A quadratic function is something like, let's say, x squared minus 4. So a line looks like 3x minus 6. What is the degree? When we talk about a line, what is the degree of this function? The degree of a line. Anyone?
First degree?
Yes, degree 1 or first degree. Perfect. What about the quadratic function? What will be the degree of this?
Two.
Yes, indeed, degree 2. Good, so let's start with this line. And just a quick refresh. So when we graph a line, so let's say this would be a line. You see, it crosses the y-axis and it crosses the x-axis. So what do we know about which coordinate of this point we know for sure and always?
Positive.
Say it again.
It's positive.
Right, but I could have graphed it here. But one of these two coordinates is always known for any point on the y-axis.
X and Y.
Yes, which one? Only one of them is known.
You said only one of them is known.
Always known for any point on the y-axis. Any point.
0.
For which one? For this or for this?
X.
Yes, indeed. So this is x equals 0. So the equation of the y-axis is a vertical line that gives it's a position. This one is x equals 10. This one is x equals -5. This one is x equals 0. It gives position. Perfect. So this is the one that we do not know. It could be positive, as I graphed it, or it could be negative, or it could even be 0. But all points on the y-axis have x equals 0. What about here? What do we know about this point, which is the x-intercept? Which of these two coordinates we know?
Four.
Which of these two coordinates we know always for sure? For this one or
Y
this?
equals 0.
Y equals 0. Very good. So this line has the equation y equals 0. This is altitude. Altitude 0. Altitude y equals 5. Altitude y equals -3. Altitude y equals 10. So altitude is y. Position is x. So this is what I don't know. So when I look at 3x minus 6, So fy or f of x equals 3x minus 6. First, I make x equals 0. How much is y when x is 0? I covered it because it's gone. Anyone?
-6.
Yes. And the ordered pair, right here, right now, not later. 0, -6. Now, I want to make y equal 0. Okay. This is 0. So I have to move -6 to the other side. When I move a term from one side to the other, what happens? Yes, I know you can add 6, but let's move on from that. So when I move a term from one side to the other, yes, Rebecca, you wanted to say something. Sorry, I interrupted you.
It becomes positive.
Yes. So we have 6 equals 3x. Can anyone tell us how much is x?
2.
That's
2.
it. And right here, right now, we write the correct ordered pair. That's all we need. We are graphing using x and y intercepts. So let's say here, graphing a line using x and y intercepts. So I have those 2 points, 2, 0, and 0, -6. Connect and extend. Sorry, I ran out of room. But we have to connect and extend. We always label the axis. These are the arrows in the positive direction. I saw it in the negative direction. There is no need, only the positive direction. And we always write the function next to the graph. So we always know what we graphed. So f of x equals 3x minus 6. So that's how I highly recommend graphing a linear function. You can say, wait a minute. I was taught to find the y-intercept or find the point and then use the slope. Yes. Nobody cares about that method. Is it a good method? Perfect method. But nobody cares. Here's why. We always have to determine the x and y-intercepts if they exist. And this is the only function that can be graphed using the slope. No other function can be graphed using the slope. Okay? Like this. So please move away from that. This is the most important. You can still use it, but you still have to determine the x and y intercepts. I'm not against the method. I'm only saying that you can use the method you are used to, but you still have to find the x and y intercepts. Any questions? Any questions? Okay, so now let's look at this x squared. This is a very simple function. It's the simplest possible quadratic. And it's a parabola. The parabola can open downward and have a max, or can open upward and have a min. It's still a parabola. There are 2 possible shapes. This one is the simplest one, and it's this. This is y equals x squared. See, notice I always write the function next to its graph, so we know what we graphed. Yes, there are more complicated situations when we have not the simplest possible one. I just wanted to refresh your memory on that. The other, I'm just going to share my screen for a moment here. I'm trying to see if I'm logged out. Most of the time I am. Okay. So I'm sharing my screen. Again, please pin the speaker so you can see this on the full screen. Okay, and I want to jump directly to page 12, I think. So there is something called compound interest. but I would like us to look at a problem with compound interest. So first I'm going to explain the formula, and then we'll come back and we'll choose a problem on how to use compound interest. Also, I wanted to show you how to enter a function. I will do that in a minute on the graphing calculator. I have an emulator here. So I will be entering in y equals all sorts, and then we'll talk about it. So for now, I just want to talk about the compound interest formula. There are two. Two compound interest formulas. One of them, we have to wait till chapter 2. It's called continuous compound interest. Continuous compound interest. The second one is what we are going to look at now in chapter R. Compound interest n times per year. So forgive me, this is my n and this is my m. 3 bubbles, 2 bubbles. So compound interest n times per year. What does compound interest mean? Recalculated. The interest is recalculated n times per year. And here's the formula. The accumulated value, I'll write these down for you. Principal, 1 plus r over n raised to n times t. What's all this? This is the accumulated value. This is the principal. P is the principal. R, lowercase r, annual interest rate. N is this. How many times do we recalculate the interest per year? T, time, in years. Because this is times per year. This has to be in years. They may try to confuse us, and they may say 6 months. We have to change T, right, the 6 months into 0.5, half a year. So careful on that. Okay. So now I would like to share my screen again. And let's choose a problem and apply the compound interest formula. So for example, we have a $100,000 certificate of deposit. Well, that is the principal. We are depositing $100,000. 2.8%. So that is the interest rate. But it has to be in a decimal form. It cannot be in a percent form or percentage. Okay? It has to be changed from percent to decimal. How much is the investment worth? Rounded to the nearest cent, because we're talking about money. At the end of the first year, if interest is compounded annually, quarterly, annually, semi-annually, quarterly, daily, hourly. So let's take a look. So I'm on page 3. Okay, so I'm going to write the formula again. 1 plus r over n raised to nt. So 100,000, this is the principal. Again, r, 2.8% changed into 0.028. Time, t, 1 year. Now, part A, annually. Uh-oh. Can you still hear me?
Yes, you're breaking up a little bit though.
So should I turn it off and reboot?
No, it's fine now.
Oh, okay. Sorry about that. Quarterly. Daily. and hourly. Here's what I recommend. Notice one thing. This is the same for every part. It doesn't matter. It's the same. This is the same for any of these, A through E. This is the same for all these. The only thing that changes is N. N changes. What is N in the first situation? Annually. 1. Very good. What is N in the second situation?
2.
2. Very good. What is N in the third?
4.
Perfect.
4.
Perfect. What about daily? 365, we consider that. What about hourly? Well, it's 365 multiplied by 24 hours a day. So this is my variable. The formula that I will enter in the graphing calculator would be this. 100,000, 1 plus 0.028 divided by x. Why x? What about n? Well, the calculator doesn't have n. I will have to enter it as x. Raised to power 1 times x. This is what I'm going to enter. I'm going to enter this formula, and then quickly, in one blink, I'll replace x by 1, x by 2, x by 4, x by 365, and x by 365 times 24. So I don't have to repeat this process again. So I'm going to share my screen. Go to the calculator. Please consider this. Clear if you have anything in there. And just enter exactly the formula. 100,000. Open a parenthesis, very important, plus 1 plus 0.028 divided by x, because x is the variable. Don't forget to put the caret, which is the power. I always like parentheses for the power. It's not necessary. It depends on your calculator, though. But for this one, it's not necessary. But I like everything that is the power to be in parentheses. That's my safety net. Okay? So now I go to second and table. Let me say this first. Second and table set, make sure, second and table set, make sure that the independent variable is in the ask mode, not the dependent, just the independent. How do I do this? Click, 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 click to the side, and enter. Okay, so make sure, because otherwise you will not be able to put in the numbers you want. And now I go to second and table, and now I enter what I want. I only want 1 and 2 and 4 and 365 and 365 times 24. And the calculator will do it. So now I go up and highlight, and then highlight, and then highlight and copy what I have. Okay? So the first one, so part A is 102,800. Part B, 102,800. Part B, 102,819.60. For part C, 102,829.54. We're asked to round to the cent, 0.54. The next one, part D, 102,839.46, because 45 is followed by 8. And the last one, so this is part E, 102,839.56. The measurement unit is extremely important always. Do not just write a number, please. Okay? 2. please. So these are the final answers. I didn't have to repeat entering this, maybe incorrectly by mistake. I entered it in the graphing calculator in y equals, and all I need to do, punch in 1, 2, 4, 365, and whatever that number is, and I got all the answers in a blink. Notice that they have to be close. If you get 50,000 here and 70,000 here and 90,000 here, the formula is incorrect. They have to be close to each other. So allow me to also put the comma where it belongs, and that's it. Any questions on this, please?